be towards the back, I think. Okay, today we're just going to learn one little added step to our ice table math. So far, everything that we've done in ice tables, we've always had zeros, like nothing has happened yet, so we know what's going to appear and we know what's going to disappear. What we're going to do today is we're going to learn what to do if we don't have any zeros. It's not at time 0, it's somewhere in that graph. Which way is it going to go? And that's called Q. Q is for initial concentrations only, where before we had zeros in our initial concentrations. Nothing has happened yet. I didn't make anything. Now it's not going to be the same thing. The equation for Q is the actual exact equation as K. We take our products over our reactants, our coefficients become our exponents. So it's the exact same thing, but instead of putting in equilibrium concentrations, we put our initial concentrations into it. And it's going to tell us which ones get the plus x's and which ones get the minus x's. Where before, we knew the zeros would appear. They can't disappear less than 0, so we knew they would get the plus x's. Okay? And the way we're going to figure out which way it's going to go is by a really good graph that actually makes really good sense in my brain eyeballs. Surprisingly, the book has the same idea in their head, but we're going to redraw it. Draw a dotted line down the middle and label it at equilibrium. When we solve for K and we plug all those numbers in, that is equilibrium. So your K line is going to be right up to your dotted line, your K bar. If we plug in our numbers for Q, we do our math, we push our buttons, and it turns out that Q is a smaller number than K. Remember, this is left, this is right. The right are the products, the left are the reactants. If Q is less than K, that means that in order to catch up to K, I'm going to have to make more products. That means my right side, my product side, is going to get my plus x's. That's really all we've done so far because we had a bunch of zeros. If we just did that math, Q is always going to be less than K when you have zeros. So we were always just knowing where the plus x's left. If Q equals K, which sometimes it is, it's kind of a trick question. It is at equilibrium. Those are the words. If Q is too far past, remember it's supposed to be here. It's supposed to be at equilibrium, at K. It's got to go back. It's got to do the reverse reaction and get rid of all that extra stuff. It's going to be, so if Q is greater than K, it's going to make more reactants. So the plus X's are going to be on the left. Because it's got to go back. It's got to make more of these and use up all the reactors. We're going to learn it by doing number 9 in sample problems. So when you're all set, can you go to number 9? They're in the back of your PowerPoint. I know, it's been 2 weeks. Okay. At 4:48, we'll learn our very last thing we'll learn for the unit is let's do that. The equilibrium constant Kc for that reaction is 50.5. So this is K. Predict in which direction the reaction proceeds to reach equilibrium if we start with means initial. Reading comprehension. 2 times 10 to the negative second moles of HI, 1 times 10 to the negative second moles of H2, and 3 times 10 to the negative second moles of I2. But look, it's in a 2-liter container. This is sneaky tricky. Remember, molarity equals moles divided by liters. And now we're in a 2-liter container, so we need to make sure we divide everything by 2. Okay, always when we do these, we start with our ice table, so I'm just going to draw my ice table. I like to do it on the right side for no reason. I just do. After we draw our ice table, then we go back and read the words and fill it in. I have 2 times 10 to the negative second divided by 2 concentration. So actually what I'm going to do is just divide by 2. And that's just me to remind you to pay attention to the liters. So we're going to write it like that. I have 1 times 10 to the negative second divided by 2 because it's 2 liters. And I have 3. Our next step would be to do our plus x's and minus x's, but see, we have no zeros. So we can't do our disappear up here that easy. That's how we know we have to solve for Q. Q is going to tell us what side is plus x's, what side is minus x's. Our equation is our products over our reactants. Our coefficients become exponents. But for Q, I'm going to plug in those i's. So now I'm actually going to button push and divide by 2 and get the right numbers in there. So get out your calculator. I'm actually going to take 2 times 10 to the negative second divided by 2, plug it in. That one gets squared. Remember, coefficients become exponents. 1 times 10 to the negative second divided by 2. When you have a second, check in with your battle buddy to make sure they understand why we're divided by 2. Hey, do you get why we're divided by 2? Do you need help pushing buttons? Why don't you go ahead and solve for x with your battle buddy? And check in with us.
All those memories you've been storing for years are wiped out. Most name brand bars and body washes you rub on your skin.
was trying to say how to do this. Once you find your plus x's and minus x's, then normally you would just like finish the problem and solve for x and do your quadratic and stuff. You just don't have to on these. But tomorrow on the partner quiz, you will. You're going to have to solve it all the way through. This is just the beginning of it. The next one you're going to do is in the worksheet packet, start at number 3. So it's a white worksheet packet, turn the page, and then you're going to do 3, 5, and then 6. It looks like this on the top. Do number 3 next. Then do 5 and then do 6.